Okay, everyone. In this video, what I'm going to do is go over putting objects inside of lists. So I'm going to go over this example that I already have typed out and just walk through the concepts of what's going on with putting objects into lists. And then in the second half of the video, I'm actually just going to walk through this example that we're just writing from scratch about working with objects and lists. So let's just start here. And if you were in class, we're working with that same example that we had where we have an employee. Employee has a class variable called PythonCo. That's the company name. You can make an employee to have a name and a salary. You can give them a raise, and you can display their status. A manager is a very specific type of employee that has all the same instance variables of name and salary as before, in addition to a department that would be like the department that employee manages. They can give them a raise. This manager can get a raise, which overwrites the original give raise. They can also give praise to another employee, and that's a method that's specific to this manager. So I'm going to set a breakpoint here and just walk through really quick, going through giving raises and stuff like that. But the real meat of this is that I want to show what happens when you put objects into a list. This is something you'll need to do for your homework with the women's soccer team, part 3 of the object-oriented programming part of it. So let's just set a breakpoint here. So we are making a new employee, and we can display the status of this employee. Their name is John Doe. They have a salary of this. We can give them a raise and show that they got the raise. Same thing for Jane Smith, who is a manager, except their raise gets to be a little bit higher since they get a bonus. The manager can call their own methods too. But what we can do, and what I want to focus on, is that we can make a list, and just like we had shown that we can make lists with strings or integers or floats, we can put entire objects into a list. So this will be a list of objects. So if we run that, and we just hover over this, you can see that in position 0, so the first position there, we have John Doe, that first employee object. And then in the second one, or the first position instead of 0th, we have Jane Smith that works in IT. So those are both stored into the list. And what's nice about lists is you can actually just append and change them whenever you want. So let's say you just wanted to add another employee or a manager. In this case, we're adding Benjamin Franklin to our list. So if we were to just run that. Oh, oops, I might step over it. Let's see. Yeah, I accidentally started another terminal. Let's go back to the first one. Okay, so we just appended Benjamin Franklin on there. If we come into here, we can see that Benjamin Franklin is now part of our list in there. You can do the same thing. Instead of appending it directly in there and calling manager or employee, you could just store an employer manager in a variable and then append it by just sticking that variable in there as well. Both of them will work. It doesn't really matter which way you do. So now we should have 4 in there. Yep, the length is 4. And this third one, we have Emma Johnson stored in there with a salary of $100,000. So if you want to access a specific employee, like we learned before, you do the list, you use square brackets, and then you list the location in the list where they are, with 0 being the starting point. So you have 0, and this is going to represent the first employee, and then we can display the status of that specific employee. So if we run that, that's going to print out John Doe, and I have a salary of $55,000. And that's because in our employee list at location 0, we have John Doe that has the function to display his status. So we can access that as long as we know where the location of that is. We can also just do that in a loop. So we have this list, we can iterate through it. So we just list the list here, we make up a variable name here to represent the objects that we want to work with. And it will step through every single one of those. So the first object in this list is John Doe. So we're gonna give him a raise and display his status. So he just got $1,000 raise. Now we're going to be on the second object in the list. So now this is going to be Jane Smith. And Jane was a manager object, like it shows up here. And the cool thing is when you have inheritance and you're overriding something, in this case, give raise does something different depending on if it is a manager or an employee. So that's called polymorphism, is the term for that. But what's nice is if you give it the same name, we don't care if in this list they are an employee or a manager. It's going to work either way. It'll just do different logic based on if it is a employee or a manager. So when we give Jane a raise and display the status, we can see that we gave her a raise as well, and it included that bonus, that extra $100 because she gets a 1% bonus on top of the 1,000. So increased from 65,500 to 66,600. So then we can keep going through. Once we run that, now we're on Benjamin Franklin. He'll print out, and then this last one was Emma Johnson. So we can access all of those methods and variables of the objects, and it's really nice when working in loops. Another nice thing to do is if you put something in a while loop, you can just access any specific object in a list that you want if you ask the user for input on which spot in the list they want to access. So let's step into the while. And I'm doing while true. That means it'll run forever until it breaks, and there's a break in here. So we'll run this, we're looking for an input, and it says enter a number between 1 and 4 to see employee information or type exit to quit. So let's say, I think Benjamin Franklin was the third one. If we wanted to see his information, we could do 3. Okay, so now in here, this is just checking if we want to exit the loop, but user input was equal to 3, not exit, so it will skip over that. Now it's checking, is the user input a digit? So this is a string function that's just checking if the string is equal to an integer. It is. So it comes into here, and we're going to convert that into an actual integer instead of a string. And now this is just checking that it actually is a valid number to say. We don't want to say something that's bigger than the length or less than the length of the list itself. So in this case, user input is 3. So that's bigger than or equal to 1. And then the length of manager's list is 4. So this is a valid value. So we'll go down there, and then we're going to print out the employee list. We said we wanted the third one, but because we start from 0, if we want the third one, we need it to equal 2. So we're going to take 3 minus 1. So that'll give us 2 in total. And then we're going to run the display status method on that. So that'll give us Benjamin Franklin and what his salary is. So pretty cool. And then that ended that. So we went up back to the top of the loop. It's still true. We're going to ask the user for anything else. Let's just do one more. Let's do the first one. Okay, it's going to step in here. It is a digit. It'll convert it into an integer. It's at least 1. So we're going to print out the information or call the display status function for the first employee in the list. There we go. And then why don't we just exit? So let's type out exit. This is going to be equal to exit. So we're going to break and exit the loop, and that's the end of the program. So we're going to end there. So hopefully that gives you a good idea of how putting objects into lists can be really useful, especially when you're looping with them. And with that said, let's jump over here to the practice problem. So here, what we're going to do is build on the practice that we did earlier. So I have a video on this practice if you haven't watched that yet. And I'm just going to copy the code over from that, where I wrote code for a vehicle class, for a car, and then we made some instances of them. So I'm just going to copy this over here into this, this right here. Just doing that so the comments are formatted right. And I'm going to just get rid of the extra comments from the last file. Okay, so we have the vehicle and car classes already written from the last practice. So we have vehicle, and this just has a make and a model, and it prints out the engine starts if you call start engine. Car inherits from vehicle. It'll get all the instance variables defined in the vehicle constructor and also add year to it. But when you call start engine, it gives a slightly different message. So, and then we made some examples of this so far. I'll just run through those really quick, just in case you didn't watch the other video. And let me actually quit out of all these and just rerun it. There we go. So we can start an engine for the car, we can start an engine for the vehicle, or start one for the car, and we can also print out the year of a specific car. So that's what we have going on so far, nothing too crazy. So first, if we want to put any of these objects into an actual list, we need to make a list. So let's just call it whatever we want. How about a vehicle and car list, and we'll just leave it empty for now. If you want to make a list but you don't know what you want to put into it yet, you can just do 2 square brackets like that. And you know, I'm actually just going to delete these pieces of code here because we're going to put in new cars to this list down here. So now let's create a while loop that's going to ask for a make, model, and year. Depending on if they give the year or not, make a vehicle or a car, and then append it to the list of objects. Then ask, enter yes to keep going, or end to exit, and loop back to the top if they don't answer no. So let's put our code here. So we're going to do while, we might change this, but we can just keep it like the last loop and just do true and then enter a break where we want to exit. So let's get something for the make. Let's just say input, enter a make. Let's do a model, input, enter a model, and year equals input, enter a year, or n if no year. Okay. So far we'll be doing this forever. So we want to make sure we provide a way to exit it. But let's do the this logic first. Let's do depending on if they give the year or not, make a vehicle or a car and append it to the list of objects. So let's do so if year does not equal n, and just to make sure, we'll also add upper to that, just in case they did lowercase n. Then this is going to be a car that we want to make, and we can add it to the list directly in here, but just to show, I'll store it in an object first and then append that object to the list. So object is equal to yeah, we want to make a car because we're checking if it's not equal to n. So if it's not n, then that means we want a car. So the car is going to accept a make, model, and a year. Otherwise, object is going to be a vehicle, and we'll just accept a make or a model. Then we have our list that we made up here, remember, vehicle and car list. And we want to make sure it actually gets stored into this list. So we're going to do dot append, and we're just going to stick the object into it. So no matter whether object is a car or a vehicle, it's going to get smushed inside of this list, and then we have access to it after that. So then let's ask, we'll just call this continue, or sContinue, it's a string. It's equal to input, and I have the message here, so enter Y to keep going or N to exit. And in this case, just to keep it simple, we're just going to check if sContinue is equal to N, then we're just going to break out of the loop. If they do anything else, it'll keep going, but that's good enough for this example. And sure, we can do upper as well. Then, cool. So I'm going to walk through this, and then I'm also just going to print out the list, which will look a little bit ugly, but it will show what's going on at least. So let's set a breakpoint here. Let's run our code. So we have this vehicle and car list, which should show up here, but there's nothing in it yet. It has a length of 0. So we're going to enter into our loop here. We're going to ask for a make, Honda Civic, and let's enter a year for this first one. Let's do, I don't know, 1998. So as long as we didn't say we didn't have a year, it should go into here. So let's step down. It's going to make a car object. It's going to pass Honda Civic 1998 into the constructor. So we can even step into that. It'll jump all the way back up into car. It's going to call the super for vehicle. It'll add the make model there. It'll add the year here. Then step back in. Now object is holding that Honda Civic from 1998. And we're going to append this Honda Civic into the vehicle and car list. So we'll step over that. That's going to ask us if we want to continue. And let's just put yes, we want to continue. We didn't put no, so it's coming back up here and it's going to ask us again. Enter make, Mazda, CX-5 from 2020. Why not? Okay. Here we go. Oh, I guess I did a car again. We'll just do one more example where we do a regular vehicle. Let's do yes. We'll continue. Enter make. Ford Escape, and for the year we're just going to put N for that. We want this to be a regular vehicle, not a car. So it was equal to N, so it's doing the else. It's going to make a vehicle. We're going to append this vehicle to the car and vehicle list, and let's just say we want to exit. So now we're going to break out of the loop, and we're going to print out this list. And you can see it gives us a list where we have the brackets here. And then every single thing in here, even though it looks ugly, this is represent a whole object. So we have a car object here, a car object, and then the last one we did was a vehicle. So we have a list full of job objects that we've made on the fly. So that's kind of cool. Then let's do something where we can actually access those vehicles that we just made. So I'm going to create a for loop that goes through each object in the list and prints out its make, model, year, if it exists, and then call the start engine method. So let's do for object in vehicle and car list. We want to print out the make. Let me make sure that is lowercase. Okay, everything is lowercase. Also print out the model. And then if object dot year is not none, then we want to print out object dot year. That should work. I'll come back to it if it doesn't. And then we want to call the start engine method. And what's nice is that because we overrode start engine, this can behave differently depending on if it's a car or a vehicle. But we only have to write start engine once. We don't need any kind of if it's a vehicle, do this, or else if it's a car, do this. We just have to write one piece of code. And because we've overridden it, it just takes care of itself, which I think is pretty cool. So I'm going to, is it going to let me step through? No, we ended it there. I'm going to get rid of this breakpoint and just quickly make some more cars. That's the one annoying thing if you're asking for inputs and testing it, but we'll do that, and then we'll start breaking once we get to the for loop here. So Honda Civic 2003, yes, let's do another car, Mazda CX-5 from 2023. We want to keep going. Ford Escape. Going to exit there. We printed it out, and now we're going to go through this list here. So our first object is that Honda Civic. So we're able to print it out, model, and we should be able to print out the year because it has a year. Year is not equal to nothing. And then we are able to start the engine. So the car's engine roars to life, and that's because start engine for a car prints out the car's engine roars to life instead of just the engine starts. So let's move on to the next object in our vehicle list, which is the Mazda CX-5. Make model, we'll print out the year because that's a car, and we can start the engine there. And this last one is a car object, or a vehicle, excuse me. So it has a make and a model, but it doesn't have a year. So it'll print those out. And vehicle objects, no. Well, sorry, there's another way to do this, but I'll check. I might even put a comment on it after I upload it. But you get the point. It's going to go through here and print out each one of these, and it'll behave differently based on whether it is a vehicle or a car object. So I'll fix this once the video is done, and I'll explain how to fix it. So, but thanks. Hopefully that helps you get a better idea of how to put objects into lists and how to loop through them and make them work. So thanks.